in 2016. That was 5 years ago. At that time, he spoke on data-dense visualizations and what to do when you have millions or even billions of data points, and how to show the data and not just the summaries. We've invited Richard back this time. As you know, he will be discussing visualizing with text. And at this point, okay, Cameron, why don't you tell the group about the website, and then and anything you might want to about Datadog. And then we'll have Richard give his presentation.
Sounds great. Thanks, Naomi. So hi, everyone. As before, Datadog is providing hosting for the Meetup. I work there. I work on data visualization tooling for cloud health, and we're hiring. So if you're a software engineer and you're interested in data visualization problems, you should come check us out. My other update is not Datadog related, and it has to do with this Meetup. So one of the most common questions that we get at the end of every Meetup is there a recording, and can I see the slides? And usually people find these things by scrolling through the Meetup comments. So we felt it might be a nice idea to have a website where you can browse all the past Meetup talks, abstracts, slides, and what have you. And if you learn something from one of these events, you can share a link to what you did, and we might put it alongside the content from the speaker. So it becomes more of a continued learning experience. So the site is in very early stage, and I've been working with my friends Vivian and Jessica on this. But if you have ideas for things you'd like to see from this website, or you'd like to help out, please reach out to us after the event. There's a form on the page that you can use to send feedback or to submit your idea for a lightning talk. I'll plug the lightning talk thing. I think it's a great learning experience. I did my first one in 2018. And it was a really great opportunity to think deeply about a data viz topic that I hadn't spent that much time thinking about before. So if you're on the fence about it, you should go for it. We'd love to hear from you. I'll pass it back to Naomi to reintroduce Richard.
Okay, I think I did introduce Richard and then realized I hadn't given Cameron a chance. So Richard, it's all yours. I don't believe in repeating the abstract and bio that everybody's read when they decided to come here. So
okay,
mentioned how you became part of our Meetup. Richard, it's all yours.
Okay, thank you very much, Naomi. Thank you for the wonderful introduction. And Cameron, thank you for hosting. I'm really happy to be speaking again 5 years later. Last time, as Naomi mentioned, about data-dense visualizations, and this time about visualizing with text. So as you probably already read in the invite, that there's a book that I've created called Visualizing with Text that just came out that I'm super excited about because it's just a huge amount of work to produce a book, and I'm super excited because it's great to finally hold things in your hand that you've been working on for a long time to create. So I'm going to kind of take a slice through the book where we go through some of the major points in the sequence and dive down into a couple of areas within here. This is actually an area that I've really been fascinated in and interested in for quite a long time, for about a decade. So even when we were talking about data-dense visualizations, this was already some things I was doing in the background. I was thinking about text and how and where text fit into visualization. And you might pause as a first step and say, why do we even care about visualizing with text? Why should text be a part of visualization? It's kind of like the opposite of visualization. Isn't the whole point of visualization to get away from text and to make pictures? So why are we even considering this at all? And the first thing that I'll talk to then is consider all the visualization that's going on today, the things that people are doing, whether they're using Tableau or Power BI, or whether they're using R or Python and the kinds of things that people are creating there is largely working with quantitative data. Lots of numbers, lots of categories of things. And that market today, you can look at the estimates, there's about $4 billion worth of software sold a year looking at that kind of data. And experts, of course, suggest that there's a lot more data that's messy, unstructured data, such as text. And that might be as much as 80% of data. So there's a lot of that data. And furthermore, textual analytics are actually the core piece of some of the biggest tech companies in the world today, right? So Google is fundamentally about working with all this messy HTML text that they're scraping from all these sites and organizing that in a way to facilitate search. And that's a $100 billion a year company, right? And Facebook, very similar. You've got a massive valuation that's coming out from being able to structure and work with text. So there, in theory, should be a very big opportunity for visualizing text and having good ways to work with and visualize text. There's other reasons to consider it too, and in the invite that we put out, we actually talked about that, right? There are serious problems that we have in our society today where text is being used and abused to do all kinds of nefarious things. And you just have to look in the news on any given day to find out some kind of thing that's going on. So, you know, whether that's a phishing attack, you know, these guys got access to all these accounts on Twitter, to all these wonderful accounts, and they use them to just try to get Bitcoin, right? That could have been far more dangerous outcome than what actually happened there. We've got this other one here on Facebook, for example, people being led with links to things that are fake information about COVID. And if you can't read it, if it's blurry here, this little highlighted piece at the bottom said, a single piece of coronavirus misinformation led to 800 deaths on Facebook, right? So really serious problem there. And then one more example over here, which is another one that's really bizarre, where hackers got access to a news website, legitimate news website, planted fake stories on the legitimate news website, and then spread that URL through social media so everybody would go to that site and read the fake stories and think that they're legitimate because they're under the banner of a legitimate news agency. So there's some really interesting challenges of how do we understand all this textual information as a society and be able to think critically and reason critically about it, the same way you have to reason and think critically about numbers. So the first step is, what do we actually have? How do we think about text when we think about visualization? And let's take a step back then and think about how we think about making visualizations today. And in most textbooks and in most visualization courses, you're going to see some kind of progression, some kind of pipeline like this diagram, where you start in the left side with data that's structured the way that you might talk about it in a statistics class. So you've got categoric data, ordered data, and quantitative data. And then you're going to take that data and you're going to turn it into different visual attributes. And typically we're talking about position, size, and color and shape, right? So you think about pie charts, scatter plots, bar charts, they're all about position, size, and color, right? And then you have marks, so you're either taking those things that you've made and plotting them as dots or connecting them together. And then finally, it's in some kind of layout. It might be as simple as a scatter plot or a graph or all kinds of things. There's been lots of wonderful research on different kinds of layouts that can be made. And so this is a really useful set of machinery that we have for thinking about visualizations and for designing visualizations, because there's lots of different combinations that can be made out of this. And you can use this to explain a lot of visualizations. So if I take a very famous popular visualization in the top corner here, you can see a plot from Hans Rosling from a number of years ago, right? It's essentially a bubble plot. And so what we're doing is we're taking numeric data, we're setting the position, size, and color based on data values, representing those as points and drawing them in a scatter plot. That's one example. Here's another example. It's a map. It's an election map from 2016. The book came out before. The book was in the works well before the last election. So this is a map from 2016 election. And what we have is basically whether you voted Republican or not. And are you guys hearing all of that in the background? Can you hear me okay? Is it all right? I'm assuming it's okay. All right.
I can hear you.
Okay. We're hearing the squeaking.
Yeah, there's other people in the house, obviously. It's fun of COVID. All right, so so this particular visualization, this election map is categoric data, right? So we've got geographic areas like states, and we've got voting like Republican versus Democrat. We connect those to color and shapes. Those shapes are the areas of the states, and we put them in a geographic layout, and that gives us our map. So that's all wonderful. That gives us lots of incredible quantitative visualizations. But what about if we have text data? What do we do if we have text data? Well, the common way that a lot of people think about that is we have tools to analyze text, to crunch text. So let's just put the text at the very beginning of that pipeline and then process it to turn it into the kinds of data that we know and work with in visualizations, like categoric, ordered, and quantitative data. And if we do that, we can use all the same machinery and everything will be good. And so then if we do that, we can take words from text, we can count those words, and we can set those to size. And what we get coming out at the end is something like a word cloud, right? And so everybody knows word clouds. And word clouds are, perhaps the most famous kind of text visualization these days, but they're not really that informative. So for example, this one here, it's coming from the text from Alice in Wonderland, and we've got all these different colors of the text, which isn't actually meaningful at all. It's just randomly assigned colors. And we have the different positions of the text, but that's actually not meaningful either. And we've got the different rotation angles of the text, which is also not meaningful. The only thing that's meaningful in here is the size of the text, but this example, like most word clouds, doesn't have a legend. So you're not even really sure what the relationship is between Alice and the Queen. Is Alice 5 times as big as the Queen, or is she 50 times as big as the Queen? So it's not really a great example. And if you think about all that machinery, it can't really work with all the kinds of things that text could potentially give you. And that's fundamentally the gap that we're talking about. So how do we figure out what are the pieces of machinery that might exist for using text in visualizations and making visualizations with text? Well, one of the ways that we can do that is to look back at old visualizations, historic visualizations. Before people had the rules and the textbooks that we have today, they didn't have those, so they could do other different things. And just for a little example of this, I'm going to start with storyline visualizations. So I really like Randall Munroe's XKCD comic. This is something that he drew many years ago, maybe a decade ago, showing the time axis is the time in the story, and then each line is a different character, and where those lines come together are where the characters meet or where they're walking along together, and the big battle scenes are where everybody connects together and so forth. So it's really a compelling representation of the structure of the story. And as a visualization community, what's happened is that people have said, wow, that's really cool and interesting. And furthermore, we can use computers to do this kind of thing that Randall drew by hand here. And we can, use those techniques that we saw in the machinery before to create other versions and extend this and make it better in different ways. And so what you get is all of this kind of riffing on the same theme of the storyline visualizations. And so it's a very narrow view of how to think about the text in the stories to just create these storylines, when in fact there's so much more that is feasible and possible. And just for example of what's feasible and possible, here's a couple of examples on the right side. So at the top here, we've got history of the political parties from 1894. There's lines twisting and weaving with the different parties of the United States over time. There's text inside the lines, big text, little text. There's little annotations of certain events along there, little call outs, lots of things that are going along. Here's a storyline from 1858, A History of the World. Again, you can see the top level patterns, the big storylines, just like you have in the comic. But again, this is all filled with text. There's big labels on here indicating different empires. There's little text in here indicating different rulers. There's little sentences in here providing other context, all organized in a storyline. So you've got the structure, but you've also got content. It's giving you a lot more for your money, so to speak, than just showing only the structure. And we can go all the way back. The last one that I have at the bottom here is Joseph Priestley. That's before William Playfair, right? When a lot of people talk about visualization, they talk about visualization being invented by William Playfair. Well, Priestley was doing timelines in 1769. And his timelines, much like the ones above, are packed with all kinds of textual information as well. It's not just structure, it's structure plus content that you've got going on there. So this is really fascinating to me that like we've got all of these great, wonderful examples that we could look at. And they're quite varied. So storylines is just one of them. And there's other ones that we could pick and look at as well. So I'm just going to cherry pick a couple other ones here. This is one of my favorites. This one, when I first found it, my response to this was, something on the order of like, just, wow, there's just so much happening in this. It's a tree. It's a tree going from left to right. The top level at the left, it's going into all of these branches, and we have all kinds of tree visualizations in our visualization community. But this is a tree made out of text. And there's so much going on in this text in here. This is actually a table of contents to the very first encyclopedia in 1728. And this table of contents is literally a paragraph that's been split apart into a tree. So I can read on the left here, knowledge is either natural and scientifical, which is either sensible, consisting of perception of phenomena and external objects and so on. And it keeps breaking down into successively smaller groups. And then you get down to these chapter headings. These chapter headings have little numbers on them in superscripts, and you can skim it as well. You don't have to read it all linearly like a paragraph. So you can just jump to any of these leaves at the end. You can see that there's some text that's bigger in capitals, some that are in italics, some that are in small caps, all to help you navigate through this thing, whether you want to read it or navigate it and work with the content. So this was like really incredible piece that I thought was showing that there is so much more possible and feasible than what we were working with and thinking about in visualization. This is a poster from 1840. The Victorians come along, the first machine age, the industrial era comes along, and now you've got the ability to make any kind of font. There's so many different fonts coming out. You can make any kinds of posters. This is just like when Adobe first came out in the 1980s, and you can make anything, right? And it's like, they've got every single font on the page. You could dismiss it like that, or you could actually take a look at it and say, this is actually pretty amazing. There's like some printer who said, I've got to catch people's attention among hundreds of posters that are plastered up on the walls around here and get that key message across. And so if you just look at it at the very high level, it says to be sold stock. Right? So its core message is right there in the big heavyweight letters that you see right away. And then if you want, you can look at it at the next level. Maybe you are interested in stock. So to be sold by auction on Thursday, the 8th of October, 1840, the stock of cattle and other effects. That still worked as a sentence. It was still semantically and grammatically effective as a sentence, even though I'm skimming it at a different level. And then the next level, you can read all of it, and you can read the to be sold stock at such and such's house, where they're located, what the exact contents are, what the requirements are to pay for it, and so forth. And it all works at all of these different levels, which is really cool. And I think at a certain level, this is way beyond our capabilities to compute today, to be able to pull apart the text and be able to create these multiple different levels of reading with a combination of visualization and textual analytics is beyond what we can do, and would be super awesome if we could get there. There's also some other fun going on in here. So just as a designer, you can take a step back and say, haha, look at this, it's to be sold stock. And the letters for stock are actually text made up of things like cows and sheep and so forth. So, you know, a lot of wonderful design going into otherwise pretty simple poster here. And there's many, many examples we can look at. So if you're in the visualization community and you look at sites like D3JS, you might recognize this as a sunburst chart or a hierarchical pie chart. This is a chart from a classroom from 1890. And of course, the interesting thing here is that everything is labeled throughout. Every wedge is explicitly labeled because otherwise it wouldn't be usable, right? There is no interaction the way that we have here. So they put in all of this text, and the text can do some interesting things too, right? So at the center, you've got bigger text that's bold and all caps, and then the branches, you can see articulata, that's in capitalization. And then the next level, you've got insecta, which is spaced out to indicate that there's a big extents there. There's a lot of insects, so the text is reinforcing what you can see graphically, and it goes all the way down at the very bottom. We're looking at things like butterflies and so forth. So when you think about this visualization and how it's used, it has almost no value at all without text. It needs its text in order to function and be usable. And of course, maps are wonderful. Hundreds of examples of maps. One of the challenges with the book is you can only get so much in there. There would be potentially many great examples. This is from Ordnance Survey, which does these wonderful maps in the UK. And one of the interesting things about it is that you've got all of these different place names on here. And the place names are not just size. They're actually packing a huge amount of information into those place names. So you've got the text itself that indicates the name of the city. Then you've got the case, whether it's uppercase or lowercase, that indicates the difference of whether it's a town or a village. Italics are used in there. Italics are used to indicate whether it's an administrative town. Font size is used to indicate the population category, as you might have guessed. And there's even font family. So most of these are serif fonts. If you look down near the bottom right corner, you can see Kirkley's Prairie, which is not in the standard kind of Times. It's actually in a black letter font because we're actually looking at a point there that is some historic medieval town or site that we have there. So you've got these 5 different variables that are packed into these text labels, and it works even if you don't know them. You can still read the place names. They're using an encoding that you can kind of figure out some of them, and if you want, you can refer to the legend and do all of it. So it's accessible at many levels for your needs. So yes, it's great to look back at these historic examples. There's contemporary visualizations happening too that aren't necessarily following those kinds of rules and guidelines that we think about. And so, here is a wonderful example of a biological pathways, metabolic pathways chart, which is massive. This is just a tiny portion of the chart, and it's all of these lines connecting all of these different molecules, and you've got little diagrams of the molecules, but it's packed with text for the text for each molecule and the different metabolic functions associated with each of them. And so this is wonderful. I recommend going and finding the poster on Rosh's site sometime. It's a diagram that's been built up over 25 years. So it's 25, no, I think it's in the 60s is when this started. So we're probably going on to well over 50 years now. Here's just a simple snapshot from air traffic control. This one's not in the book. I found it really hard to find a good air traffic control image and get usage for it. One of the challenges with writing a book is you have to track down all your usage rights. If you're thinking about an air traffic control screen, you've got the markers on there, you've got the text on there. You really wouldn't want to have an air traffic controller needing to use a mouse and saying, uh-oh, I've got a problem there. Let me move the mouse over and try and get the tooltip on that thing. And then maybe the icon moves a little bit and the tooltip disappears. You can see there's a massive usability problem with that. And the kind of data that you have in here, like flight numbers and destinations and aircraft type and timestamps and so forth, that's just not information that works well in other forms. And so having that information right there front and center becomes critically important to flying safely. And it's all around you. It's lots of great little examples. This is Yayoi Kuzma and Stephanie Posavec did this great edition of Alice's Adventures in Wonderland. And so, the text doesn't need to just be stuck in prose paragraphs. You can work with things like capitalization and italics and size and the leading, how tight things are, and even spacing. Some of the words are moving up and down on their lines here to fit in. As Alice is jammed in her room, the text is jammed on the page. So it's a wonderful play. And then even things like the polka dot code on the call. The interesting thing is that text visualization is in front of you all the time when you write code, and you're probably not even thinking of it as visualization. And just like that map that we were looking at a couple of slides ago, there's a huge amount going on in here. We've got foreground color, background color, italics, bold, solid underlines, wavy underlines, font size, capitalization, symbols, delimiters, lots of stuff happening in here, right? All to help the programmer read their code and skim across the code and find the bits that they care about much more quickly and easily as they're writing that. And then one last example here. I think this is a great example. This is Kate McLean. She does a variety of really fun, interesting maps. This is Smell Map Amsterdam from 2014. And I think it's a really wonderful reimagining of a map. In very light white and gray in the background are the streets and canals of Amsterdam, the standard map, right? So you can do that. But on top of that, she's got this notion of creating these contours and paths that describe smells. And it's a way of conveying a sense of place that's very different than what typical maps do. And so if we look at the red line, for example, you probably can't read it. It's probably blurry from the zoom and the compression, but it says, "I love the smell of flowers. They make me smile and they bring such life into the atmosphere. A girl on a bike zooms by. Her floral perfume hits my nose and makes me think of a perfume shop. Spring blossoms, green, spicy, fresh," right? How do you convey that kind of information on a map that's just looking at quantitative information and maybe some categoric information? It's very evocative. It goes beyond just individual words and really helps you associate all kinds of things that you have with spring and flowers, which is very appropriate for the time of year of our session here. So we can look at all that information. We can spend a bunch of time analyzing it, pulling it apart, looking at all the different things that are happening in all of that. And I'm going to skip across all the analysis and jump to what that actually means, right? So this is the diagram that we were at maybe 10, 15 slides ago, talking about all the machinery that we have to work with to build visualizations. And now what we can do is we can layer in all the extra things that we've learned from looking at all of those examples. And what are some of those extra things? So right at the very first step, data is more than just categorical ordered and quantitative data. There is literal data. The phrase, "what is the use of a book?" has a lot more semantic meaning associated with it than just those 7 words, right? Then we can move on to visual attributes. And we can say, well, we know we have things like position, size, and color, and we can use those things like position, size, and color on words. So we can now work with those types of things in conjunction with words. But furthermore, we were able to uncover that there's lots of other variables that only text gets. You get things like font weight, you get things like italics and capitalization and different typefaces and underlines and how the spacing is. Lots of different things to work with there. And then we move on to marks and we say, well, there's some way that there's a relationship between all of these textual elements and the marks like points, lines, and areas. So we can work with things at the level of the individual letters. We can work with text at the level of words. We can work with it at the level of phrases and sentences, or we can go all the way to things like paragraphs and documents. And those kind of line up with the points and the lines and the areas. And then finally, when we get to layouts, well, of course, we can use the text on those layouts, but we can also have some text-specific layouts. So there's things like tables tables, for example, that work very well with text and can be utilized too. So what we have is incredible new machinery. It can be put together in lots of different ways. You don't have to use just one at a time, just like you saw with some of the maps in this example sentence here. So now we've got a huge amount more to work with in creating visualizations. And we could stop there. That's about the first half of the book. The second half of the book really says, so what, right? Like if I gave you a library like D3JS to work with, it's a wonderful library. But part of what makes it such a wonderful library is not just that it's a great library, it's got really great examples. So I felt it was really important to make some examples of what you could do with the new machinery. And the book's got a lot of different examples, and we're only going to go and look at a couple of them in here this evening. There is a companion site to the book where some of these examples are running live. So this is the companion site on it. If you just look at my Richard Brath at .wordpress.com, you can find it under books, and there's all kinds of stuff on here, but eventually you'll hit some of the examples, and then we'll just start with this really simple example of a labeled scatter plot. So, much like a lot of scatter plots that you see, there's a bunch of dots. In this case, it's a bubble plot. So the size of some of these dots are a little bigger than others. And this is a data set of countries around the world. So we've got about 200 dots on here. And we're looking at death rates on one axis and birth rates on the other axis. This is just some demographic data. And so what we're seeing is, countries where unfortunately there are very high death rates and very high birth rates in the top corner here. And like we mentioned before, you can point at these things in standard visualization techniques, and you'll get a tooltip that will say something like in this case here, that particular dot is Niger. And we can see that. Or we can say, oh, there's a big dot here. What's that? I can guess that's either India or China. Well, that one's India. The unfortunate thing that you're seeing me do here right now is that I'm having to do hunt and peck. I'm saying like, oh, there's an interesting dot. What's that? Oh, there's an interesting dot. What's that? So you're putting a lot of effort back on the user to start looking at and seeing and figuring out what kinds of patterns and what kinds of things are going on in here. And what we could do is we could just put that information right into the plot. So instead of using filled circles, we'll just use the 2-letter country code, the standard country codes that you see in internet domain names. And when we do that, we don't have to hunt and peck. We can just read across patterns really quickly. So in the top right, again, this may or may not be clearly visible through Zoom, but we've got RW for Rwanda, MW for Malawi, ZM for Zambia, Uganda, Burkina Faso, Mali, Niger. Well, okay, so these dots up at the top right corner, they're African dots, right? You can kind of see that. Well, what do we got down at the bottom here? These are countries where there's a very low death rate. So what have I got here? I've got KW, Kuwait, AE, the Emirates, QA, Qatar, Bahrain, and so forth. Okay, so we're looking at the Mideast down here. And then what about up here? This is high death rate and very low birth rate. What am I looking at? I've got Latvia, Ukraine, Russia, Estonia, Bulgaria, Belarus. So we're looking at the old East Bloc over here. And so these kinds of serendipitous patterns become accessible when we use the text and make that instantly visible to us. We don't have to spend all that extra effort of formulating a question, moving the mouse, looking at the value, moving to another one, remembering what the previous one said. The cognitive load is so much lighter and easier just by simply putting in some labels that work with the visualization. So that, I think, it seems very obvious at a certain level, but the benefit needs to be articulated sometimes so you understand just what value is being created there. And so then, like I said, there's many, many other examples that we can do here. Another favorite one that I have is taking line charts, and instead of having a separate legend somewhere and then trying to associate back and forth between the legend and the line, is just put the text right on the lines. I'm not the first to do this. You can find historical examples that do this. This is actually looking at stock data. And these are like stocks that have the biggest price change from a number of years ago. And so these are interesting because, well, they're making news. There's something going on in these stocks. So we can put not just the stock name on the line, we could actually put the news directly on the line as well, right? And again, this can be interactive too, even in these kinds of environments, because you know, news changes, new news comes out. So you could even imagine doing something like having news scrolling by on the line of the stock. Not sure if that's actually effective or not, but it's one of the things that could be done. And using, in this case, the software D3, it's like a line or two of code. It's not exactly difficult to use that. It's part of the SVG spec. You're just accessing and doing that. I'll move on a little bit further now into some data sets that are larger, bigger chunks of text and some of the kinds of things that you might be able to do with them. And so now we're getting to a little bit more of processing the text as well as thinking about how we visualize the text. And this is a data set from the Georgian era, Georgian London, 1760 to 1800. And these are inquests. And the coroner inquest, each inquest is summarized in a neat sentence. So we have sentences like, Mary Roberts drowned herself, suicide. John Snook stabbed in the back with a knife, homicide, and so forth. And you'll notice these patterns in these sentences are pretty simple grammatically. So even though I don't write a huge amount of code, I can write some Python code and detect and pull out things that are verbs, for example. I can pull out things that are objects, and I can pull out things that are subjects. And then you can say, well, I could take those things and I could stitch them together in a different way. I could put them together into a hierarchy. So we can see, for instance, under all the inquests, we've got things like drownings, we've got things like stabbing. Underneath stabbing, we've got knives and swords. So there's things that are sharp underneath stabbing. And then at the level beneath that, we've got the names of the people. So who are the victims that we're seeing in these deaths. And then there's a level where we could go to what are the different verdicts that we have associated with them and so forth. Essentially, it's a hierarchy. We've taken this text, we've turned it into a structured hierarchy. And we've seen examples where we can visualize hierarchies. If we just take standard visualization techniques and visualize that, what we get is, for example, a tree map. So the tree map is representing this hierarchy. It's only showing 2 levels. The text doesn't fit very well. There's big areas, there's super tiny areas. You can't display the text in the super tiny areas. So maybe our techniques, we need to look at other kinds of techniques. We need to reach a little bit beyond some of the layouts that we have in visualization. And so for this one, what I suggest, maybe the visualization representation is closer to the kind of thing that we would use for a book or a dictionary. And so we can organize all of that just like you'd have in a dictionary, your top level words and then your lower level words and so forth. And so if I zoom in on a part of that, we can see that, for instance, we have beaten is the verb, and then under beaten, we've got the different objects. So we've got things like axes and bludgeons and fists and bodies. We have crushed. Under crushed, we have things like barges, beer, brick, building, butt, carriage, cart, chimney, house. Being crushed by a chimney or being crushed by a house, right? Not very common ways of dying anymore, but were ways of dying, and quite a number of them occurring back in those times. And these can be interactive as well. We can try and take a look at this here on a 4K screen. The entire thing is visible and interactive. Of course, if I reduce it down here, it's just going to turn into little tiny blobs, but we can zoom in again. And there's all kinds, of course, of interactions. It all is text. So, we can zoom in here, and any one of these are hyperlinks. So we can go and look at Daniel Williams here, who fell from a horse on a certain date, and we can open up the link. And the cool thing here is that we're actually back looking at historic documents from, in this case, 1777, when this inquest was filed. And the full details of that inquest are visible in this next image that we have here. So if you want, you can get from a top level down to this historical analysis in a really interesting flow. There's other things, of course, you can do with visualization. So we can do things like, let's take a look at the different kinds of deaths. We mentioned before that there were homicides, suicides, and so forth. If we just look at the homicides, we can see, for instance, over here, there's a big block of lots of red names, and they're all underneath people being strangled. So strangling, for instance, was a common means of homicide in those days. If we look at suicides, we'll find different ways that people did suicides in that time. Hanging, we've got a lot of names under hanging here. And cutting your throat apparently was a way to commit suicide in Georgian London. So all kinds of things. One last interaction, let's just zoom out a little bit here. It is text, right? So the standard kind of tools that you have in your browser are accessible. I'll just type in child well, let's put a highlight on it, but it's really hard to see in here. It's a yellow highlight. That's not coming through too clearly, but you will see yellow highlights coming up in things like births, for example, and strangulations. So children, unfortunately, being stillborn is a common cause of death in that period. So we can see how far our society's come as well when we look back at some of these examples and all the things we can put in. And there's more that we could get into, but I think we'll carry on from here. I've shown you a number of examples from the book. This is an example actually from the firm. I work with a company called Uncharted. The book was just a side project. So Uncharted, we build all kinds of visualizations, often working with very large data sets like we had previously talked about, dense visualizations. And this is a visualization that you're looking at in the back here with, it's a graph. So it's a network, lots of different documents all connected together. And part of what we're doing is looking at different parts of that network and calculating communities, nodes that are associated together, and drawing a circle around that so you can see these groups. And then at a certain point, when you've got lots and lots of nodes, you've got lots and lots of circles, there's lots and lots of different groups in here as well. And then you still get back to that problem of how to make it usable. What is that circle? What is this circle? And you could again use tooltips, but you could also just make it directly visible. And what we're doing here is actually making it so that text appears on the rings of the circle. So once that circle gets to a certain size, or once you zoom in to a certain distance, those circles are going to become visible, and you can see the text on all of that. And this is actually a whole bunch of scientific documents that are actually about coronavirus and other related viruses. And you can see we zoom in here, we're looking at different variants of alpha coronavirus and beta coronavirus and gastrointestinal viruses and the documents associated with these. And so that's basically it. That's largely what I wanted to talk about. There's many, many, many more examples in the book and different ways of like, how do I have examples of working with paragraphs? Yeah, here's an example working with paragraphs. We have an example working with quantitative ones. Yeah, there's some examples working with quantitative values on top of text. Are there examples of just working with individual characters? Yeah, there's things that are working down at that level. So the book is really packed with lots of examples, trying to give a sense of many of the different kinds of possibilities that are in there. And that's essentially it. But wait, I did start this whole thing talking about fake news and phishing and trolls and bots and so forth. And I'd like to be able to say that, all of this came about, and now that we have this, we can solve these problems like fake news and phishing and trolls using visualization with text. The reality is it's not that simple, right? I think it's really good to have these new tools to be able to work with. It would be really powerful to bring these tools to bear on some of these topics like fake news and phishing, but it really is, there's a lot of complexity to figuring this out. And so here's just a couple of quick little examples. I showed you the scatter plot before, where we had the different circles in the different countries. Well, this is the same idea, except we're now looking at a scatter plot of companies. And for each company, we have a score for the sentiment. So whether the sentiment is positive or whether the sentiment is negative, and what's the sentiment that we're seeing in mainstream media on the axis at the bottom, and what's the sentiment that we're seeing in social media on the vertical axis. And when you put those two together, you'll see that, for example, there are some companies that are doing rather poorly in both categories. Both social media and mainstream media are not having a great time with Hewlett-Packard. They're saying negative things about Hewlett-Packard at whatever was going on at that point in time. Up here in this quadrant, we've got people saying positive things about the companies. So Honda and Intuit and Baker Hughes, we're getting positive commentary about them. Where it starts to get interesting then is where you've got like some kind of deviation. So down here in this quadrant, we've got people saying positive things in the press and negative things in social media. So down here, we've got things like Volkswagen. This is February 2017. So this is probably around the time of Dieselgate going on. And I'm just going to hazard a guess that the mainstream media is positive and social media is negative. So it's probably that Dieselgate has already broken. Mainstream media is now already shifting to a more positive tone because people are getting fired and Volkswagen is starting to fix things in their business, but people are still pretty ticked off because they have to get their vehicles repaired and serviced and so forth. So you can see how you could start to be able to use these kinds of things to explain what's going on, particularly if I did have the ability to link back and get through to the source documents and so forth. This was just something that I put together this morning because I had an old data set to do a quick look at it and just reuse some of that code. Here's another example. This one is actually from the book. This is just the top 5 tweets about hurricanes on September 5th, 2017. And so what we have here is essentially a timeline. So we've got time on the x-axis, and the vertical axis is the number of retweets. So these are the most popular tweets about hurricanes, and the line is going up higher and higher the more and more it gets retweeted. And so here we can see there's a line here that's comedy. Oh, we good, Trump won't let Jose into the US by one person. So there's a popular tweet. We can also see a tweet here that says, Irma is now a category 5 and it's larger than the state of Ohio. So, very factual kind of tweet that's getting a lot of interesting retweets. There's tweets about prayers on here. Keep Dominican Republic, Cuba, and Bahamas in your prayers. And another one here about, Google 21, 25, 26. The eclipse was on the 21st, Harvey began on the 25th. There's some kind of numerology thing perhaps going on in that tweet. So very, very, very different kinds of content is bubbling up and becoming super popular, right? So you can see there's different patterns in the uptake, and so forth on here. So you can start to see how these tools might be used to look at some of this data and try to understand, maybe some of these tweets are things that you'd want to inspect a little bit further and understand a little bit more critically, digging into them. Or if you were the organization that needed to figure out, are all of these tweets good? Should some of these tweets be removed? What kinds of tools would you use? Maybe a tool like this might be helpful. I don't know. It's a bigger problem than just visualization because you're touching on things about privacy. You're touching on things about regulations. You're touching on things about hate speech and libel and crimes. It's as a society, there's questions that have to be raised and answered to help figure out how we're going to address this. It's not just visualization, but I think visualization becomes a really important part in helping solve this problem. So with that, I think we can get to wrapping up, and it looks like my computer decided to lock up just on the last slide, which is almost perfect timing. So we'll wait for PowerPoint just in case it wants to come back. The last slide was just simply going to say thanks. And it did have 1 or 2 other things on there. The book, for example, is available at Amazon, I know somebody tweeted last night and said, Amazon's showing out of stock. I asked the publisher, and the publisher did tell me that Amazon seems to be fragmented, and so some places it might be out of stock and other places it might be in stock and so forth. If you are having any issues, you can try your local independent bookseller. There's lots of great local independent booksellers. You can also find it on the publisher site, Routledge. It is available on their site as well, and they ship free worldwide, I believe. There's also a code for a 20% discount off of their site, and that code is on the next slide. So maybe if we do some Q&A, then I can get the slide going during the Q&A. But I'll kill PowerPoint in the meantime and come back to that. So with that, thanks very much. I hope everybody enjoyed this. Cameron, did you want to start with questions, or should I scroll back through the chat, or do people ask questions out loud?
I think so. People should post questions in the chat as they have them. I can kick things off to give people some time to write. First, thank you so much. This was a super organized and very captivating presentation with all the different examples. I was very glad to be at my own screen so I could zoom in and read the labels up close, which would be harder in a live presentation and if the slides were up on a wall. So I thought that was really convenient. My question was, something that's striking to me about these text-based visualizations compared to other forms of less mainstream visualization techniques like parallel coordinates or sunburst or other sorts of things is that they seem to me very accessible to people, even if they're not coming from a, so to speak, data viz background, because the text gives them a bridge into things. And I was curious, in your experience with sharing these different text-based visualizations with different audiences, what sorts of text visualizations have people found most confusing and not able to just draw on their background as readers of text in the everyday world?
So that's a great question, and I would say there's lots of examples that are in here. Some of them I have found that people have a very strong visceral response to and say, that's great, I love that. And there's other ones that are definitely in the zone of head scratchers, where people say there's like too much going on. And so one of the things, I think it's a general criticism in visualization that I've done for a long time, is that you can really pack a lot of data into a visualization, and it's possible to overload a visualization. And you can use interactive techniques, for example, to get around that. And I don't know how far we want to go into interactive examples, but this is an example, much like we were looking at the map, where there was a lot of different things going on all at once. And so this would be the kind of thing that people would go like, yeah, there's too much going on. I'm having difficulty discerning everything that's going on in here. And just for reference, this is Wikipedia articles where each line here is a different Wikipedia article that we have. It was an article of the day back in a certain time period, and what we have is page views, is how far the bold goes across. The blue is indicating the word count, how many words are in there. So we've got a lot of blue here on Hillary Rodham Clinton. That was a very long article that we had for Hillary Rodham Clinton. The underline is the number of edits. So wow, there were a lot of edits also for Hillary Clinton. Year's weight is one of the variables in here, and it looks like it should be italicized or something that's not coming up. And then, for example, color underneath is the number of watchers. There's lots of people watching that page as well. So it's overload to try to keep track of all of those. And one way of solving this is to say, just make it interactive. Just turn off the stuff that you don't want. So if you are doing a task where you do need to synthesize across 6 different variables, then it's pretty cool that you can turn all of those on. But probably most of the times you're really interested in just one thing. So just focus on that one thing and just set it for that. And so then perhaps it's a little bit more consumable and usable if you're working with just those one or two things that you're trying to assess and compare. So for example, here now we can see we've got a lot of watchers on both Hillary Clinton and Taylor Swift, but Taylor Swift has got a lot more bold. What does that mean? It meant Taylor Swift got way more page views than Hillary Clinton.
Post questions in the chat. If anybody has questions, post them in the chat, and then we can invite you, if you prefer asking them in person, we can invite you to unmute yourself.
I can bring a follow-up while people are typing, building on this example. So something else that's striking to me is that this is a book with interactive examples, and that's not super common in the world of books or DataVisBox. So I was curious, like, what was your process for bringing these examples into the text? Did you like write first and do the examples, or was it like while you were authoring, you made examples? How was that?
So it's a good question. The book itself grew out of a PhD. I did a PhD from 2012 to 2019. And so what you're seeing is a version of parts of the PhD. So it grows out of that, and there's more that's been added and reorganized from there. There's aspects of a PhD that are less relevant. But from a design perspective, it's a really good question. If you're trying to probe a design space and you're trying to create different examples, how do you do that? And I'd say it'd be iterative, it'd be back and forth. I would try out something, I'd look maybe at a historical example and say, oh, that's really interesting. What'd they do there? Let me try that with some data. Let me try putting together a little bit of code. And typically when I say code, I'm using either JavaScript in D3 or I'm using Python. And so let me try out a little bit of code and then see what I get. And then, maybe the thing that I created isn't really that useful and effective as I thought it might have been. So I'm missing something. So I go back and look at the example or see if I can find other historical examples. So it's very much a back and forth iterative process in these, especially when you're trying out some of these new things. You're probably not going to get it right on the first try. There's examples that never made it into the book because they just didn't really quite work, for example. There's lots of little clunky things that happen. So I showed the example of the text in the scatter plot in the PowerPoint, which isn't running. And so the collision detection approaches inside of D3 assume things are roundish or squarish, and it does a really nice collision detection automatically. Text tends to be wider than it is high. So the collision detection doesn't do a good job on that by default. So then you're writing more code to make that work. And so there's these things that you assume that might just work right away that don't they need more fiddling in order to get them to come out okay. I noticed your point. Sorry, go ahead.
Go ahead.
There was a point that you had that said when I did the tree map has higher accuracy for the areas that it's representing, and the text has lower accuracy because you're putting the words and spacing the words out. I would say that there are one thought that I would put against that is that all visualizations are lossy. All visualizations are bringing some decision into what data to surface and how accurate to surface and other variables to make less important and less accurate. So you're always dealing with a trade-off in any visualization that you pick. And so then it's a trap to say, oh, this particular technique is more accurate. Yes, it's more accurate for that one thing, but what did it sacrifice to get that?
Yeah, I would say less accurate. It's just you're losing one piece of information, and I agree. There's a trade-off there.
I'm not losing. I'm just
what you're-
reducing the accuracy on it. Size is still relevant. I can see that there's more people who have died by strangling than that have death by chimneys falling on them.
Right. I wanted to ask a question, if I could, about reproducibility, because from my point of view, like doing the label, I love this idea of like using text for visualization, or like kind of thinking of it as like both combining text and more traditional visualization forms. But in terms of reproducibility, the labels are the hardest part of making any graph, and the least reproducible, because depending on the length of the name, you might need to split it into different rows, or, you know, so the kinds of visualizations that you're doing, like, do you think about it in those terms? Like, is this something that I could do with any data set with text in a similar format, or does each one have to be, I could imagine, like, for example, that stock announcement kind of has to be done, hand done, line by line.
Yeah, so I think it's a good question. Text is messy like that. We have words that are a single letter, and we have words that are, you know, 10, 20 letters if you go into different languages. If you do a translation, you go to different languages, the same text can become much longer or shorter. It's not nicely, it doesn't behave nicely. It behaves differently than some of the other types of data that you might work with. And so then that means you do have to accommodate and deal with that. So in the country example that I had, you know, it's you know, we're using 2-letter codes, which are really handy because countries have 2-letter codes. But there are lots of other things where you don't have codes. You've just got like really long labels. If you look at, I think in the book I have an example using consumer price index data. So consumer price index data is all the things that change prices that they use in the government to figure out and calculate inflation. But the problem is some of those things are really, really short labels like pork, and some of those are really long labels like automobiles and vehicle accessories. And like there isn't a 2-letter code for these, or if there was a 2-letter code, you wouldn't know it and I wouldn't know it, right? Like there's maybe 100 experts in the Census Bureau or Department of Labor, or whoever it is that does the calculation. They know that code, but we don't, right? So how do you work with that? And I think you need, that's the reason why it's important to have a lot of different ways of working with the text, lots of different approaches to working with the text. So being able to work with it at the level of little individual words, or being able to work with it at the level of phrases, or being able to work with it at the level of sentences. Because if you approach one problem and you can't squish it down to just individual words, then you need to back out and say, how do I work with this at the level? I need to go up to the level of phrases, or I need to go up to the level of sentences.
Thank you.
Cool. It looks like Robert Monfera has a question, or just a comment, but I'll check. The text occlusion. Text
occlusion. So I don't see it, but it's a good question. And I meant to talk about it, but obviously I didn't. You can see it right here in the scatter plot. So in the scatter plot, we have dots. Now, occlusion occurs in other kinds of visualizations as well, right? So we do have dots on top of dots. And the way that we solve for that in most kinds of visualizations is that we'll use things like make sure that the smaller dots are drawn on top of the bigger dots, use a little bit of transparency, for example, so that you can see that there are dots over top of dots and so forth. Text really performs poorly when you start putting text on top of other text. It becomes hard to read. And so as typographers, one of the things you're always trying to do is make sure that your text is legible. So you fail miserably if your text isn't legible. You've kind of missed the first hurdle on usability if people can't read the text. So one of the things that you will notice here is that the text has moved apart. There's a collision detection algorithm going on here. So those two bubbles right there for AO and TD are right on top of each other, but the text has shifted a bit, so they're not overlapping. You can also see in here, there's a few more in that space as well. And so the text is nudging itself away a little bit. And this is, as I mentioned, just D3, and the algorithm is just the collision detection. So here's the D3 collision detection algorithm being used and pushing things apart. And it happens so quickly that you don't even see it pushing apart for these little bits of text here. That will break down, of course, if there's too much text and there's just not enough space to push it all around, you're going to have stuff go off screen. So you can see some areas where there's a little bit more density, right? It gets a little bit harder in there. And so some of these are a little bit harder to see, right in the middle of this cluster here. That PE is bordering on illegible. And also immediately below that, you can see MA and MY. Because they're two-letter codes, you know that they're distinct, and there's an ever so slight hue difference, but there's the danger there that you could have misaligned two things and the end user could misinterpret that as a new word. But these are all the kinds of things that we deal with in all kinds of visualizations, right? If I make a stack bar chart and the two colors are too close to each other, then I might misread the bars on there. I've got things that are variables, bars that have no height at all or null values. These are all kinds of things you have to do in every visualization. And so text has its own set of rules and things to work through when you're dealing with text.
Great, thank you. So next we have a comment from John. I'll check if he wants to say it out loud. No, I don't see him in this. He had a question about convincing people, especially qualitative research away from word clouds.
Yeah. So word clouds are super popular, and I would argue that they're super popular because they're really visceral, right? Like, whoa, there's this kind of dynamism to all of this text coming at you, and the different angles and different colors and different sizes. So it's got this kind of visual appeal. And I would argue that some of the stuff that I showed doesn't have quite the same kind of visceral appeal that a word cloud would. At the same time, I would argue that when you take a big text that's got all kinds of wonderful things happening in it and just put it into a blender and chop it up into little individual word pieces, you're losing so much context, you're losing so much insight, so much meaning by doing that. And there's an argument to be made about, well, what about some of those phrases? Those might be really important. Or what about some of those relationships between, like adjectives? Like, how would the queen be described if you were to ask something about the queen? What about, some of these aspects? And so bringing in more meaningful data and not just focusing on word frequency, which is really what the TAG cloud does, or the word cloud does. We need to move people off of thinking about visualization of text as individual words or transforming it into structure and just showing the structure. You need to think about text as something being richer and much more meaningful.
Great. It looks like John isn't in the chat anymore, but I think that's a good case that it can help people when they're trying to do this.
Yeah. I see Tom has a question. Is there a rule of thumb for having too much text? Is there, if there is such a thing? It's a good question. And I think it depends on your audience and the use case. So always when you are thinking about visualization, I would come back to, I've shown lots of examples. I've hinted at some of the use cases that are there, but I haven't really spent a long time on those. And professionally, if I am building a visualization, I'm going to be starting instead with the user. And what's the user need to do? It's a user-centered design process, UCD. And so then starting from there, if it's somebody who's walking along the subway tunnel at Times Square, there's probably not going to be a lot of text in it because they're just walking by. You don't have a lot of time. It's like that image that we saw that said "to be sold stock," right? You've got to convey things pretty quickly. On the other hand, we do a lot of work with people who are subject matter experts. And these are people who are used to working with and being in the depth and the thick of the data. And for those people, you probably could have a lot of data visible and accessible to them. So have a lot of text. And so that's why the example with the deaths in George and London, right? We had 3,000 deaths, I think. So there's probably 6,000 words, a first name and a last name associated with each of those, and some causes and other things. So, there's a lot of text on that screen that you can see and work with. And I think for somebody who might be investigating that era and spending a lot of time working with that kind of data, it might be very insightful and meaningful to have that density accessible and visible, right? It could do things like, how common is the name Thomas in George and London? Is George more common in George and London? I don't know. I mean, but those would be the kinds of things you could ask right away, just using simple browser find mechanism. And since I do have the slides up, let me go and find that last slide that I was mentioning, because I did say the publisher gave me a code this morning and I put it on the slide here. So you can see that. So if you are having trouble finding the book elsewhere, it is available on the Routledge site. If you just search Routledge Brath or Routledge Visualizing with Text, you'll find it. And then I guess I haven't bought the book myself from the site. Eventually there'll be somewhere that you have to enter in a code, probably on the shopping cart, and then you would get the discount there. And also on the final slide here, it's really great as part of the book process to be able to work with lots of other great people in the process. So in that iterative approach that I was talking to, there were times that I reached out to other designers, other researchers, typographers, to try out some of these ideas with them and say, this isn't working. What am I doing wrong here? And as part of that too, some of these people said, I'd love to read the book, and got some wonderful reviews from some of these people, which I think is super cool. So there's a few of them on the website. I put 2 of them on here, but I think it's a wonderful contrast to have great quotes from both Ben Schneiderman and Nigel Holmes about the book.
Yeah, this looks great. We'll put a link to this on the event page after we share the recording. I have another.
Any other questions? I want to really thank Richard for a delightful talk. Everybody enjoyed it. If anybody would like to speak at the April meeting, it will be sometime in the last half of April. If we have enough speakers, we'd love to hear from you. Send an email to me, nbrgraphs@optonline.net. It's on the Meetup webpage. Again, I'd like to thank Richard. I'd like to thank Cameron for hosting once again, and thank all of you for coming.
Okay, thank you very much. I do see 1 or 2 last questions just bubbling in here. So I see a question from Philippa. I hope I pronounced that correctly. Would you have tips on how to start when conceptualizing how to visualize a big body of work, say of a government institution or a library? And I think that is a wonderful question and a very big challenge. It's not easy at all, just given the scale and volume of information there. I do think there are a variety of different possibilities. So one possibility, and this goes beyond myself, there's a wonderful paper called The Bohemian Bookshelf. It's a research paper that I found inspirational. And it talks about how to make visualizations for libraries. And so that's one good one. But then in my own work, in here, you can see where we start taking like 3,000 documents. And in that case, we could pull apart certain pieces because there was consistency there. I've thought about using a similar technique for working with news headlines. So what happens if you have 50,000 news headlines? They don't follow as strong a grammar, so they're harder to work with. We do work at Uncharted, as I've mentioned, with some big data sets as well. And so sometimes what we do there with documents is look at different ways of creating linkages between them. There's cross-references and citations that you can use as a basis for forming a network and building a big graph, and then using graph-oriented techniques like we were showing on some of that virus and COVID data and adding text in. But there's other techniques again too. So there are established hierarchies like Library of Congress and Dewey that provide this potential to navigate from a top-down kind of perspective. And then it would be interesting to say, if you have a structure like that using automated techniques for topic detection, so you can pull out like what are the different subtopics within geography that maybe the Dewey system didn't automatically figure out, but we could use natural language techniques to figure out like what are some of the subtopics in there. And then me personally, I would be going in to say who has written, it would be a great tool for me to say who's written the books about how to handle labeling on maps, because the people who create maps, the cartographers, have the exact same problems that we were showing back on the bubble plot of how do you get the labels so they don't overlap. It's not the first time somebody's addressed this problem. So in that case, I'll say thank you very much. Appreciate it. There's email address there if people do want to follow up with me directly. So thanks everyone. Have a good evening.
Thank you, Richard.